Hi everyone, welcome to our March Bash, which is the theme of modern JVM development. So just a few announcements before we start in. So firstly, thanks as ever to yourselves and to our presenters for attending. We recognize you have a choice when it comes to how to spend your lunch hour. And in this current world of distributed working, well, you could be lying on the sofa in your pajamas with Netflix, eating peanut butter directly from the jar. So thank you for being here instead. Personal vote of thanks to my colleagues Zara and Ryan for helping to co-organize all of these sessions and making me look good. So as with all event management, 99% of the effort, it's going on behind the scenes. Yep. So speaking of other events, our friends down in Cork co-organize RebelCon. They've launched a survey. We'll put a link to it into the YouTube messages there. And that's to determine interest and topics for this year's event. So just in case you haven't heard of RebelCon, they're very similar to NI DevConf here in Belfast. They're organized by the community, for the community, very strong focus on being inclusive, very strong focus on promoting good mental health in the profession. So it's a great event to participate in, and I think it's going to be virtual this year, I believe. So you don't even have to do the 4 hours in the train. And then finally, my friend and partner in crime, Eamon, he's an excellent article just up about the new features in TypeScript and using recursion and type mapping. So if you're looking for a brain teaser to end the week off, that will hopefully fit the bill. So that's it. That's all the announcements out of the way. So without further ado, I would like to call on Nicolai for our first talk. Yes, welcome to Bash. The floor is yours. Yeah.
I got. Oh, that was quick. Okay, let's go then. Okay, so we're going to talk about Java after 11. The plan for today is we start with the Java 11 code base, and then we take it all the way to 16 and maybe beyond. And I'm going to amaze you with how much changes. Or rather, I'll still amaze you, but not as much as I hope to, because we only got like 30 minutes, and I could amaze you for like an hour at least. So I'm going to be quick about everything. As Brian Getz once said, I prepared too much, so I'm going to talk too fast. So the talk is a showcase, not a tutorial. This is not about teaching you how to use these features. It's just showing off, you getting interested, and then following up on your own. This was created with a lot of help from people in my Twitch channel. They came up with at least half of the examples, so credit to them. The slides are online. So you can go to slides.nipafx.dev, and you will see Java after 11 on the top right, so you can see the slides. It's not, yes, dev bash branded, because A, we had to change it quickly for the show, but also B, GitHub told me that the build timed out, so I have to look into that later. You can see the demo project that I'm working on under github.com/Java after 8, which is what this was called originally. But if you were looking for something that actually goes into a little bit more detail on the individual features, you can go to demo-java-x, also on GitHub, nipafx. All those links are in the slides, of course, and you can follow up later for more of this. OK, so let's start. Java 11. That was released 2.5 years ago. In September 2018, and free support by Oracle ended a couple of months later, but the community at large still gives support until like 2024, and so there's also different ways to get free support and commercial support, and that is one of the reasons why so many people are here. It's the first modern Java release with long-term support. It has a solid feature set, right, starting off with Java 8's Lambdas, and then everybody's favorite edition, the module system. Well, it's my favorite edition, actually, but that's a different thing. It's stable, it gets backports, it has great support. So I understand why many people are on this version if they made the jump from 8. But Java 11 misses out on a couple of very interesting recent developments. We had a bunch of new language features that are really, really interesting. APIs were improved, the JVM improved, particularly in performance as well. So there are a lot of things that you're missing out if you're still on Java 11. And my goal is, as I mentioned earlier, to make you curious, to show you what you're missing out on, and then to make you reconsider that maybe it is actually worth upgrading past 11 and going with these faster 6 months releases. And the way we're going to do that is we're just going to code. I'm just going to show you. Here we go. I'm just going to show you this project, and we're going to do things to it. OK, so what does the project do? The code is too much to explain, and it doesn't matter for most of the refactorings anyway, how exactly it works. But what it does in general is there's a bunch of things here that I made and wrote, for example, blog posts. There's a blog post here, right? So that's the text, and it has this front matter. That's what the Markdown people or Jekyll people tend to call the stuff you put in front of the text. It's meta information. What's the title? What's the date? What's the description of this article? Blah, blah, blah. The program takes all of this in, articles, talks, videos, parses it, tries to figure out how related they are, comes up with the talks that are most related to another talk or post or video, and then gives you a list of recommendations. So for example, let's say you've read the Code First Java 9 tutorial, then why don't you read this stuff next? That's what this is. It's basically a small recommendation engine that I actually plan to put into actual use on my blog post, on my blog at some point, but I didn't get to that yet. But it does that, right? So this is the output of the file. Now we can run this. We can, of course, build it with Maven and then do the right Java incantation on the command line and see how it performs. But I'm too lazy to do that every time, so I wrote this small script. It shows you the Java version it's running on. It builds with Maven quietly. And then it runs the program 10 times. And it runs it 10 times, so it can give us a not totally unrealistic rough estimate of the runtime. Note that I'm at the same time having a camera running and streaming all of this up to StreamYard, and there's other things going on this machine because there's a whole set of browsers that I didn't close. So this is not a proper performance management. It's far off. It just gives you a rough indication of what's going on. So this seems to take about 1.3 seconds, which I feel is longer than it usually does. And the code has at the moment 2,020 lines of code, which is probably the more important stat. So keep a lookout for these two stats as we go through the versions. So this is on Java 11, as I mentioned. If we go to the POM here, you will see it mentions somewhere Java 11. There you go. And now we're going to go up. So if you ever thought that upgrading Java is scary, it's not. See, this is all I had to do. Switch it to 12. Re-imported the project. Everybody can do that. All you need is a project without dependencies. No, seriously, though. You can do the update past 11 quite easily if you have few dependencies or all your dependencies are up to date. In even other cases, you should definitely give it a try. But yeah, if you have lots and old dependencies, it could be more challenging than just bumping the version here. There's one small addition in Java 12 that I want to start with, and that's on completable future. If you know the completable future API, at least somewhat, you know that it's quite a complex beast. It has a ton of methods. And the reason why completable future has so many methods is that it does a lot of different things, and some of them are orthogonal to one another. Like, I want to handle the good case, or I want to handle the bad case. I want to do this on any thread, or I want to specifically do this in a different thread. I want to call a method that gives me back a result, or I want to call a method that gives me back a completable future of a result. So what I just told you are three different either-ors, and you have a reason to combine them any way you want, ending up with 2 to the power of 3 8 cases. So that's where this combinatorial explosion comes from. That is the completable future API. But this combinatorial explosion wasn't explosive enough. It wasn't complete. And one of the things that got added in Java 11 is basically the flat map to the map that is error handling. So this exceptionally call on a completable future says, OK, if something went wrong, please do this instead. The unfortunate detail in this specific instance is read user config already gives me back a completable future. So I would end up, if I would just say, OK, exceptionally do this, I would end up with a completable future of a completable future, and nobody wants that. So instead, what we'd have to do is we have to call join in here, and that's not ideal. And so the solution to this is, since Java 11, sorry, you have this exceptionally compose, which you can pass a function that gives you back a completable future. And there you go. That's one of the additions. Another one is, if you do it like this, the completable future API does not guarantee that this will actually run on a different thread. It could be the same thread. It could actually be the thread that gathers the results. It's not specified. It's up to the thread pool to decide what's best. So you can force it on a different thread by calling async here, by adding async to the name. That was that's possible for many of the completable future methods, and it's now also possible for for error handling. So those are two things that are new here in completable future. Another thing that's pretty neat, but where the example that I have here is a bit complex, is a new collector called the teeing collector. if you ever had a situation where you have like a stream of things, and what you want to do is you want to collect them. Let's say you have a stream of numbers. You want to create the average, but you also want to create the sum. There's a collector for each, but you want to do both. What do you do then? This is where collectors T'ing come in. Collectors T'ing says, okay, run the first collector. It's like a T, right? So it runs, this is the stream API at the bottom, and then the T goes like this, and it runs this pipeline, this collector, sorry, and this collector. And then you specify a method that takes these two results and puts them together. Okay, so this is something that happens occasionally when you during the collection, you kind of have like intermediate results or like two different results that you want to collect. And I have this situation here. I have this relation here, and I go through this pipeline. I mentioned I don't want to go into detail, but the point is I can do this with a T'ing collector. And I'm just going to copy paste that from my notes. So I don't want to talk you through this too much. And now I have to import a bunch of things. Let's see. Let's start importing. Where's more errors? There's another error. Import. Yes. Collectors mapping is something that already exists, which I use here as well. Should be a dot here. What am I missing? Oh yeah, right. The collect call would be nice. No, it's not this. It's the dot collect, of course. Now we're there. Okay. So what this does is, this is one collector that I use, and we're not going to look at that. This is another collector that I use. And then this function takes the result of the first one and the result of the second one and puts them together. And now you could make the argument that, but Nicolai, this is much worse than it was before. And yes, in this case, it potentially is. But what you might be missing then is that the classes that I had there before, the code that I had there before, used classes that I just created to capture these intermediate results. And I don't need that anymore. So I can kick that out. So that's at least one upside. So this example of the T'ing collector is not the most succinct, but it is a valuable one. You can see here that I'm using averaging double, which I otherwise would have to compute on my own. Another thing we can do in Java 11 is looking at class data sharing, which improves your launch times. But we're not gonna. We're going to skip that. And when we come to Java 13, also the only very interesting improvement that I managed to squeeze into this code base is also application class data sharing. So we're going to skip Java 13 as well. And instead, we're going to come to Java 14. Now, I do want to go through a few of the updates with you, though. So I have the Git history here, contains all the changes in small steps. So let's go here. Let's go and check out this one. I would probably need to throw away all the changes first. There you go. And then we say git check out this one. I should probably do this in IntelliJ, right? But there you go. We now check out that command. And now let's run this one with Java 13. So I asked SDKman, which I can only recommend everybody to use if you want to use different Java versions. SDKman is amazing. So let's use Java 13 now. And now I'm going to run the stats again. And if we see performance changes, these might be due to class data sharing, because we're now not loading all the classes on boot. Instead, we put all the classes in an archive somewhere, and now we can just use that archive. And what we see is we dropped, well, 20 lines of code. No, not the largest, not the biggest amount, right? But we dropped the command, the runtime as well. But as I mentioned, this is like a little bit higher than it usually is, I think. So it's more like 1.2 seconds usually. But we got out like 100 milliseconds going from 11 to 13 and using the archives. So that's good. OK, now let's go to 14. And let's use a cool new language feature that was added in Java 14. OK, there you go. Change to 14, re-import the project. And then let's go to type genealogist. OK, what does this thing do? Let's have a look at the method. The task of a genealogist is given two posts, find out how related they are. And they can do that in all kinds of ways. And what this one does is, actually, it's not so much about recommendation, relation, what this one does. It's more about recommendation. So what this one does is, it looks at the type of the second post and gives it a score depending on what kind it is. Basically, the idea here is, hey, if it's a video, I want to rank it higher because maybe I want to recommend, to all the cool videos that I did instead of the articles. Okay, so I do this switch here over the class's name because the post that we have There's an interface. We have different kinds of implementations. We don't know which one. So this is a horrible way to switch over the type. There will be better ways to do this in the future. But for now, that's it. That's the way we do it. We get the type, the simple class name of this instance, and then we switch over it. And if it's an article, I give it a score of 50. If it's a video, I give it a score of 90. You see where this is going. This is unfortunate because it's really roundabout. Like first I declare the variable, and then I have to assign it, and I have to remember to break, or otherwise I fall through, and then that's not ideal. So in Java 14, switch expressions were standardized. You can now use them without having to unlock them as a preview feature. You can just go, okay, long score. That will be switch over this, and then in the case it's an article, the result should be 50. And case it's a video, the result should be 90. And case it's a talk, the result should be 20. Okay, this is a couple of advantages. One of them is I don't have to prevent fall through. That's pretty good. Another one is the compiler checks exhaustiveness. That's why I get the compile error here. The compiler says, like, okay, look, you're switching over a string. I'm pretty sure there are more than 3 strings out there in the world. So what if it's one of the other ones? So it realizes now that this is not exhaustive. So what I do now is I say, okay, in the default case, the score is 0. And there you go. And later, this comes together nicely with 2 other language features, which will be sealed classes and type pattern matching in Switch. And then we can do this much more cleanly and without the default branch, but we don't have all the pieces for that yet. So we'll have to wait for that for, I don't know, a couple more Java versions. Because that was switch expressions. I really need new features. The best thing is no fall through, which I always hated with a passion. So I'm happy to be rid of that. Okay, let's run this again. And this didn't work, probably because I didn't switch Java versions. Okay. So I'm not expecting many changes here, right? So we dropped a few lines of code, and then also update the Java version, which I don't think have much of performance impact. Looks like I got 100 milliseconds slower. Remember what I said about the reliability of these measurements. But it worked, and now I want to break it. And I want to break this program on purpose. So let's go to create, to config. There it is. This is has a create method here. Just for fun, let's break something here. Let's just return. That's easier to do this. Sorry, to just do this here. We're just going to return now. This is on purpose. All I want to do here is force a null error. NPE, sorry. I want to force a null pointer exception. So once again, let's build this and run this. It should actually exit on the first failing run. Let's see whether it does. Yeah, it does. Okay, look, what you get here is exception in the thread main, null pointer exception at main. It's in the main class. I got that null pointer exception in the method main. Okay, so let's go to main. Let's have a look here. It said line 30 in main. That would be here. It said there was a null pointer exception here. Oh, that's unfortunate. Well, actually, like if you closely look at it, you can actually know that it must be config that is null, because there's no other way to get a null pointer exception. But generally speaking, the error message is not overly informative, right? It just points at the line and that you get a null pointer exception. And for developers, that's usually enough, right? We can open the code in our IDE, we can take a look, we can figure it out. But there are situations where that's not the case. Maybe you have first level support that can actually deal with these kind of failure analysis and can help a customer if they have a problem. But they would like to know, they could potentially know more about the, or could benefit from knowing more about the program. And there's a new cool command line flag that is called show details in exception messages. So let's have a look at one of these scripts. Let's use the run script. This is the script that runs the application. By the way, you see it runs as a module, by the way. That's pretty nifty. And we can add this command line flag here. Show code details in exception messages. Whew, that's a mouthful. Okay, let's run this then. And now I get a different output. Now I get can't invoke the method config.article folder because config is null. Oh, look at that. It tells me what method was supposed to be called, or specifically what the null pointer exception was about. It could also be, if you want to unbox null, there could also be a null pointer exception, right? So it tells you more details about that. And we'll also try to tell you what the name of the variable was that was null. And if the variable is not a variable, but if it's a method call, like if you chain method calls and one of them is null, it will also say, try to infer that and tell you that the return value of this and that method was null. So this really gives you a bit more insight into what caused the null pointer exception. But of course, that's not a real life problem, right? We all use optional everywhere. So we never have any problems with null pointer exceptions in Java. So maybe it's not that important of a feature after all. That's my personal opinion, by the way. Use optional everywhere. I'm not in the majority with that opinion. I take it. Okay. Let's have a look at the next one. Let's go to Java 15. Once again, do the update here and re-import. And now I want to show you something that could cause some head shaking, but I have a good reason for this. I showed you that the output of this program is JSON. Of course, if you want to output JSON, you create a JSON. You take some JSON library on, right, to do that for you. Well, yeah, that's okay, I guess. And I think that's the default way to do it. But look, I did it with some string concatenation, and all it took me was like 20 lines of code. Well, no, actually, that's not true. It's 25 lines of code instead of a full dependency. Of course, I don't escape stuff, but it's also my own input and not user input, so I don't have any reason to distrust it. There are trade-offs here, I agree. But also, it's mainly here because I want to show you text blocks. So there's that. So if you look at this here, I carefully formatted this string to look, somewhat like what the result will be. So you can guess, okay, there's a tab, and then there's an opening curly braces, and then there's a new line apparently, and then more tabs, and then, okay, so apparently I'm putting together. Why is the new line here? Shouldn't it be here, by the way? It's a bit weird that's in that spot. So I'm trying to put together something that, as a result, will look like, oh, it's gone now because I deleted it. Damn it. Well, you saw the output earlier, right? So it looks like a JSON file. But it's hard to guess. Like doing stuff in multiple lines and with indentation in Java before Java 15 sucks. But in Java 15, we got text blocks. They were introduced in 13 as a preview feature, second preview in Java 14. In 15, they were finalized. And IntelliJ already nudges me towards using it. You can see it, right? It's highlighted here. I can say replace with text blocks, and it does that. So three quotation marks are the opening delimiter. Oh, sorry, the three quotation marks and a new line. The new line here is part of the opening delimiter. And actually, we can do better than this. We can actually put the tabs into the code base. And I'm not sure whether you can see that on stream, or rather on your end of this of the event. But there's a thin green line here, right in front of this string here. There's a thin green line, and IntelliJ puts it there to indicate where the actual indentation of the resulting string starts. So that's pretty cool. Like this part here, this is accidental or incidental indentation. It's the indentation of the code. It's not the indentation of the string. The indentation of the string starts here. So these two tabs will be in the resulting string. And these three tabs, these three tabs won't. So that's pretty cool. So that way I get the result that I actually want. Okay, I can do the same thing elsewhere. So for example, we can do the same thing here. Actually, yeah, right. So let's do that. That's that one. And then we can use another one here where we have three tabs, and then this, and then title, and then there you go. 2, 3, wait, did additional indentation. And the other good thing about this is, and IntelliJ already did it here, and here I would have to do it manually, is in text blocks, or rather the other way around, text blocks still recognize escape sequences, right? These are not raw strings, so you can just put anywhere there, anything there, and it will be like one-to-one the resulting string. That's not the case. You still have to escape certain things. On the other hand, you also don't have variable interpolation. So these are two like opposing things that you can do with the string in the middle. You could go into raw, like just take the input as is, Or you could go the other direction and say, no, I want to interpolate variables there as well. These text blocks do neither. We might get a raw variant of text blocks and of strings at some point in the future, but text blocks don't do either. They're just normal strings, except that they span several lines. But the good thing is that because they use 3 quotation marks as a delimiter, the single quotation mark is no longer special, and so you don't need to escape it. And that means if, for example, I think those are better use cases for this for the text blocks than I showed you here, maybe you have some tests, right, to run over, like maybe JSON snippets or HTML snippets, and they need to read them and process them. Then you can create snippets for your texts very, very easily within the test, snippets for your tests within the tests. That will be very straightforward then. And then you don't have to escape single quotation marks, which is handy because these are the most common ones in HTML and JSON, right? So you can get rid of a couple of those backslashes as well. Okay, now I said that we don't get string interpolation, meaning if you want to use actual variables like I do here, right, this title later gets replaced, down here gets replaced. So if I want to do stuff like that, then I don't get that out of the box. But I'm pretty sure you know the string dot, oh, wait, this one. I'm pretty sure you know string format, right? Wait, I'll get there. There you go. Okay. This one. This is the static import. It's string.format, right? You use these %s, for example, to put a string there. So you have the static method call, and then first comes the pattern string, however you want to call that, the format string, and then comes the stuff that you want to put into the variables here. Java 11 added a method that makes this working a little bit smoother with text blocks, where you can just call formatted at the end. So now there's an additional instance method that you can call, and then that gives you the same behavior exactly. And the good thing about this is if you have like a multi-line text block, it's more feasible to put the formatted rather, the call at the end, then instead of putting format at the beginning and then the long text block, and then a couple of arguments after that. So I think this just looks better. It's very straightforward and very simple. Okay, now let's go to 16. 16 was released, what, last week, I want to say? And yeah, last week. And it contains a real doozy. This one is really, really cool. That would be records. So let's go to records. Let's see. There's a POM here somewhere. There it is. Let's go to 16. Okay, let's import that one. And then let's have a look at records. So what are they? Let's have a look at these guys. I showed you earlier what an article looks like, right? It has this front matter stuff. And when this gets parsed, it ends up in an instance called article, right? That's this one. You can see the title and the tags and the date and the slug. They're all here. Title and tags and date and slug and the description. And some of these are just stupid wrappers around a string, really. So let's, for example, say, let's go to title. So this title is just basically a string. It has a string field. It has a string argument for a constructor. It has an accessor for the string. It uses the string in equals and uses it in hash code, and it puts it into toString. And that's a lot of effort for something that should be fairly simple. And with Java 16, with records, it becomes simple. And the reason is that a record has an underlying semantic that expresses that what you're doing here is not having a class with encapsulation. No, what you're having is a collection of data. And that collection of data has a name, right? Like everything, every type in Java, it has a name, in this case, the title. But you don't want encapsulation. That's the deal. I don't care about encapsulation. It's just a collection of data. And then the compiler can be like, aha, if that's the case, then you know what? I can do a bunch of things for you. So if you write string text here, what it can do for you, it can generate this one. You don't need to create the field anymore. In fact, you cannot create fields. The deal behind a record, as I mentioned, is you don't have encapsulation. So if you don't have encapsulation, you can have other fields. These components here are all the fields you're ever going to have. You don't need to create the accessor. You don't need to create an equals that tests that. You don't have to have an hash code that uses that. And you don't have to provide a toString method. But as you've just seen, you can still override all of these. And that's what I also do with a constructor. Technically speaking, I wouldn't need a constructor. this would actually be a valid record. Could be done at this point. But I don't quite want to be done because I do have some checks that I want to do. Given the text, I want to make sure it's not null. I want to remove quotation marks, and I want to make sure that the resulting quotation, unquoted text, is not empty. So I want to do these checks, and that's what I still need a constructor for. But I can still do a little bit better. Let's say I don't have just a single field here, but like a gazillion, right? Like that happens occasionally. You have like 4 or 5 fields here. Then you don't have to repeat them all here, because the constructor, the canonical constructor, also takes all of these arguments. You can provide additional constructors with fewer arguments, but by default, you will have one constructor which takes all of these arguments. And for that case, you can turn this into a compact description of the constructor. So you don't need to do this anymore. So what you can do instead is you can just implicitly take all of these arguments as a given and then do stuff with them. You can even reassign them. And then after this code ran, after that is when the resulting variables will be assigned to the fields. So we can actually make this, even if we want a bit shorter, we can do this. That would be equivalent. Oh, sorry. This would be equivalent to what was there before. And now, as I said, I don't want to explain all of these features in detail, right? And we can. But there's one more thing that I want to show you about records. And that is that records give up encapsulation. But other than that, they're still like more or less normal classes. They have some limitations. They are always final, implicitly final. All the fields are always implicitly final. But other than that, you get most of the things, or all of the things that you can do with regular classes as well. So in this case, for example, I implement an interface. So let's just do the record refactoring by IntelliJ, convert to a record, and poof. Oh, it didn't actually remove the equals and hash code. Damn it, I was too eager there. I have to do that manually. But we have to check, of course, right? We first check, does equals and hash code really only do the thing that I expected? Does it really only take these fields as input? It doesn't have to. I can show you another example if we have time for that. So, okay, we can do the refactoring here again. We can just say, okay, just check whether this is not null. Do the, okay, that's great. But what I want to show you is I can still have a method here that compares the additional methods here, in this case, a compare to method. So I can just do the normal class thing and add more functionality. I can also implement an interface here. I can override equals. I can override hash code. I'm not going to do that, but this would be a class where we would want to override equals. Article can also be turned into a record quite smoothly, actually. But if you look at the implementation of equals, then it doesn't use all the fields for equals. It just uses one field. That's not a problem. You can just override equals and hash code, keep these 2 methods around with the behavior that you want, and just remove all the other stuff. So once again, the cool thing about records is, and people might miss that, people will see this as, oh, we can get rid of boilerplate. And yes, you can, and that's pretty cool. But that's not the first thing you do. The first thing you do is you express to your colleagues and to yourself, probably in the first line, and then your colleagues, and then also to the JVM and the compiler, this is a data collection. And that means implicitly then, okay, you get all these fields and all these accessors. You get all of that by default, and then you can change the things that you want to change. You can add constructors. You can maybe override accessors and do something in them. Or there are not many things you can do here without breaking the contract of records, which is you shouldn't do something like this, for example, and change, or I can do that anyway, but change the value of the return type. Sorry, change the value of the instance that you return. You should definitely return the fields straight away, but you can override equals and hash code, as I mentioned. Okay, great. So now let's have a look at the clock. Garth, can I still take a minute or two? If not, you will just jump in and interrupt me, okay?
No, keep going. Absolutely, you're all good. Yeah.
Okay, great. So one more thing I want to do is I want to go into sealed classes. So we're on Java 16 right now. Sealed classes were first introduced 15 or 16, but as a preview. I think 15 as a preview feature. And in 16, there's still a preview feature. And what that means is I cannot just use them. So let's write something out that will get a compile error for now. So let's say I want to say public sealed interface post. And now I get a compile error. And the reason for that is that I did not unlock these preview features. The reason why these preview features need to be unlocked is that, yes, you can use them, but you should only use them in lab projects where you just play around a bit, maybe even in a small corner of your production project, but you should not be able to ship that code to your customers, to your users, without them noticing it. Ideally, you don't do that at all, but we cannot have accidental proliferation of these kinds of features, because they may still change. There may still be a difference between the 16 version and the 17 version of sealed classes. They could even disappear entirely. Unlikely, I guess, but they could technically. So that's why you have to unlock them specifically. And the way you do this, for example, in Maven, is if you want to have the compiler plugin here somewhere. Is it not here? Oh, I thought it would be here. OK, let's add a configuration for the compiler plugin. Maven compiler plugin. No, we don't need that. And now we can add command line flex. OK, so we need this enable preview feature. And we don't only need it here. We also need it on Surefire, because you need to add this feature during compilation and then again during execution. That was the step where I meant, like, you cannot accidentally leak this preview features. The JVM will refuse to run code that was compiled with this option if the JVM does not also get this option. OK, good. So now we can re-import. Does IntelliJ get this by default? It does. OK, IntelliJ caught this. So now otherwise you would go here into the project settings and switch here preview sealed types, which it already did for the module, I guess, even though it doesn't show up. It figured it out somehow. OK, so what does it mean? What is a sealed type? A sealed type is a type that is somewhere in between a final type that can have no inheritance, or a regular non-final type that can have all the inheritance in the world. You can, do some tricks with package visible or private constructors even, but generally these are the two choices: no inheritance or full inheritance. And sealed classes or sealed types, sealed interfaces put you in the middle. You can have inheritance, but you can decide who can inherit your from this class. So here, for example, say public sealed interface post permits, because there are only these implementations, only article, talk, and video exist. So we can list them here: article, talk, video. Let's ignore these compile errors. I can fix them there, but I'm not gonna. I just want to show you the effect of this. The effect of this is, well, once again, you communicated something to yourself, to your colleagues, and to the JVM, namely that you intend only specific extensions of this class. And the way that we can use this is basically in the switch that I showed you earlier. What I write now is not legal syntax yet, but it will hopefully maybe be at some point, where you can say, if the post is an article, then I want to, make return 50. And if it's a video, I want to make it 90, and for a talk, I want to make it 20. And the cool thing is, if this would compile, which it doesn't yet, to give it a year or two, hopefully, then I wouldn't need this default branch anymore, because the compiler knows, hey, wait, a post can only be one of these three things. And then you can do this. And then if you add additional extension to post, if you have another type that extends this, you have to add it here, and then you get compile errors here. This is basically like a visitor pattern, but much simpler and more straightforward, and less indirection. OK. Last thing I want to do is, let's throw all the changes away. Let's check out the branch that has all of these properly written out. And let's run this one more time. Oh, yeah. Once again, makes sense to use the recent Java version for that. So let's build this one more time. And let's see what we get. OK, so first of all, performance is about the same, right? We went from about 1.2 seconds, as I mentioned, that's more like the default, to 1.1 seconds. So it decreased a tiny bit. It depends highly on your app whether you will see performance improvements as well, but the chances are good. Garbage collector, the implementation of hotspot, all of these aspects always get a lot of work between each Java release, and you see a lot of improvements there. We also dropped the line count from about 2,000 lines to about 1,600 lines. Most of that are records. But the cool thing about that is it did make the code more compact, but it did not come as a detriment to readability. The code is still as readable as it was before. I'd argue even more so. Specifically with records, the reason why they're shorter is not because they take the complexity and condense it, and now you have the same complexity in fewer lines. No, they take away the complexity. They show you don't have to read through all of these getters and equals and hash code and constructor to figure out whether this is just a simple data carrier. No, you can just see record, oh, it's a simple data carrier. So it reduced code and gave you a piece of information that you would otherwise have to deduce yourself. So yeah, we dropped like a fifth of the code base, and I think that's always an achievement if it doesn't come at the cost of readability. Improved performance slightly, used a bunch of cool things, and there are way more cool things that I'm giving up my time slot now. But yes, here in these slides, you will show you the things that we have seen, and then all the features that I could not cram into this small project. There's more here. So for every Java version, I put a bunch of things here that could not quite make it into the final result. Okay, that's that. As I mentioned earlier, I'm Nicolai. I'm a developer advocate at Oracle's at the Java team at Oracle, and you can follow me on Twitter and elsewhere, and you can go to insight.java. Yes, that's the URL. .java is a top-level domain, and get more information about recent Java releases. And now I'm finally done. Thank you very much.
And thank you. Thank you for a wonderful talk. First question, I think the move to Oracle is a relatively recent development, isn't it?
Sorry, which one?
The move to Oracle. So
yes. That happened last week of February. Yes.
So congratulations. Well done. Yeah.
Thank you. Yeah. Before that, I was just hyping Java on my free time. Now I can do it on paid time. That's actually quite the improvement because I spend a lot of time on that.
Yeah, so your hobby is your full-time job, so living the dream, so well done.
Yeah.
Cool. So questions. First of all, whenever we're talking about records, I think people very commonly get records confused with value types, which was a different feature that was proposed. So
yes.
Just to be clear, records are allocated on the heap, aren't they? They're not.
Yes. So records. So yes, you're totally right. Records and value types, they look similar on the surface because they both talk about something that is mostly data. But what you do here is you enter a deal with the JVM, basically, and the deals are very different. Records this is just a named data carrier. I don't need encapsulation. I give me the boilerplate, basically. And the deal with value types is I don't need identity. Give me the performance. And the value types are now at the current proposals are called primitive types. And we will likely get something like primitive records. So these things are orthogonal. You can combine them. And my personal guess is that will happen in a lot of cases. I'm really curious. Like I personally like all the examples that I showed you now I don't know why these wouldn't be values as well or primitive objects as well. So I'm really looking forward to getting a better feel for when things are one but not the other.
Yes. Yeah, no, very good. And then a slightly more philosophical question, if I can ask your opinion on it.
Sure.
As you know, whenever they added the Streams API to Java back in Java 8, it was to facilitate parallel programming. That was the goal. So they said that this Streams API is not to turn Java into a functional programming language. It's to it's to enable parallel programming. Yeah. But then the way it's turned out is that most people are using the Streams API for ever more functional style, programming in Java. So do you think, is there a tension there? Is that something that's going to cause problems?
That's actually a good question, and with not a simple answer, I guess. So yeah, first of all, you're right. The parallelism was brought up as one of the main reasons. I wouldn't say it's the only one, but brought up as one of the main reasons why streams are cool. I don't use them for that much. The main reason is in a larger program, they use the common fork join pool. So all your stream pipelines end up in the same pool. And then by default, so does completable future. So you may end up with a lot of different tasks that you probably don't want to, or maybe don't want to prioritize in the same way, in the same pool. And that's not great. And it depends on what you do. If you have a server backend, and then you don't know how many parallel stream pipelines you run in parallel, so that can be hassle. I think they're better suited to stuff where we have control over the input, where I'm doing some batch processing or something. I think that's where they're getting more use. Where I personally more look into using them. So I don't think that parallel use is actually that ubiquitous of streams at all. And then I would always say by default, don't do it. So like parallel streams are performance improvement first and foremost. And with all performance improvements, measure first and carefully and after and see whether it helped you. So there's a great talk by Stuart Marks about, it's called Thinking in Parallel, where he and Brian Getz on there as well, where they talk about parallel streams and thinking in parallel in general. I can highly recommend that. And yeah, so my recommendation is by default, don't do parallel streams. Do them after you found out you got a performance problem and that they are the good way to improve it. So what else do we use streams then for? I love streams because streams are building blocks to things I otherwise have to understand from actually reading the code. It's like with what I mentioned earlier with records. A record tells me what it is. I don't have to look carefully through it. In a stream pipeline, if it says map, filter, collect, I see what it does. Without looking at the functions, I get immediately an understanding of roughly what's going on. And we've got so used to reading for loops that I think most people are just so adept at it that they will say, like, I can see it in a for loop. Yeah, but because we spent like 10 years like looking at them. Like if somebody who did not do that, explaining what a stream pipeline does counterintuitively, it is much more simpler, right? Each element gets mapped and then gets filtered and then, blah, blah, blah. And I think that's to me is the great selling point of streams and why I use them so darn often is because I can express and read the actual behavior of the code much more straightforward.
Yes.
Unless exceptions or other things get in the way.
Yes. No, absolutely. And that's the way I love to think of it as well, that, if somebody shows me a loop, I see a loop, but if somebody shows me a map, I know it's a transformation. If somebody shows me a filter, I know you're trying to make the thing smaller. If I see a reduce, I know you're trying to produce some kind of summary value and so on. So it's just much clearer. Cool. Well, listen, we could keep going all day, but we can't. So I will dismiss you at this point. So thank you very much indeed for a wonderful talk. Yeah, and I will summon Amy.
I was summoned.
Amy, yes, indeed. And the floor is yours. Yeah.
All right, I'll banish you. Shoo. Yes. Hello, thank you, Garth, and thank you, Nicolai, for a wonderful talk. You're a braver man than me to take on live coding in this way. So, yes, hello there. I am Amy Crockett, and I am going to be shipping it all the way to production. This is a slightly more DevOpsy talk than the others, but hopefully nonetheless interesting. So, a brief introduction of myself. Ooh, hang on, A brief introduction of myself. As I've said, I'm Amy Crockett, and I'm a software engineer at Instill. And as I told the census last Sunday, that means I write code. Now, I've been doing that for about 10 years now, and for the past 3 years, I've been doing that at Instill. And Instill is a software development company, which also offers consulting and training, if you ask very nicely. But actually, what a majority of the company does day to day is write code. And we do that with one goal in mind, and that is getting it out to production and out to customers. However, the route by which it gets there can sometimes be just a little bit complex. So some examples from around the office, maybe your services have to be released in a certain order. So first service A, then B, then C. And if you've only made a change to service C, you still have to follow that chain because dear only knows you might destroy the whole system, which wouldn't be good. Or perhaps when it comes time for release to production, there is the one designated person who is jumping onto a remote login to jump onto another remote login to jump into another remote login, tunneling along the way and copying a jar file as well. Or perhaps the release is rehearsed the day before and everything goes out, everything's grand, hunky-dory, big thumbs up, but then those changes get pulled back because it is just a rehearsal, people, doesn't count. And that's just the process of getting code out to production. That's not even taking into account the differences between a production environment and a development environment. So what external services are used? How do those differ between the two? Hopefully, fingers crossed, there is a different database between your development and your production, and that will need switched over. And also, what about how the system is linked together, and does that change as it goes along? All of this kind of serves to make releases large, cumbersome responsibilities within the team. And while it is satisfying to finally get that code out, it feels like it should be slightly easier. Now, all of that contrasts quite starkly with what I'm used to with my current team, where developers have immediate access and control over multiple environments, including production. And there is no need to rehearse the release to production. There's no need to release them one at a time in a certain order, because the entire system will be pushed out as one lump, and it's only one release. And this approach makes it simple to implement changes, and it seems to be growing in popularity as we perfect how to use the various technologies to create this smooth road to production. So this talk is kind of an introduction and an overview to this approach. So without further ado, let's get to it. So first off, these are the 4 technologies that are used in the current approach to create this pathway to production. So first off, there's Kubernetes, and it is going to create a series of namespaces in the cloud. And really, these are going to be the environments through which code progresses to get out to production. Next, there's Helm, and really, it's just a package manager for Kubernetes. So it dictates what will be installed on every namespace. Easy as that. And then there's Docker. Kubernetes and Helm are dependent upon containers in order to build up the system. So Docker builds those, simple as that. And then there's Jenkins. And of course, Jenkins is involved here. There is a lot of repetitive building and deploying and making of things in here, and Jenkins is just going to automate all of that. So that's Jenkins, Docker, Helm, and Kubernetes, 4 technologies which are going to play nice together for this approach. Next, there are just a series of assumptions I'm going to make for the purpose of this talk. First of all, there is a microservice system laid out as shown in this diagram here. Also, there is a suite of tests attached to this system, and those tests are accurate and correct, because remember, your system is only as good as your tests. Don't forget it. Next, there are already some namespaces set up with Kubernetes. Just makes life a little easier. Next, there is a Docker Hub and a chart museum also set up in the cloud, and these are going to hold our Docker images and Helm charts respectively. And finally, a Jenkins pipeline exists and is customizable to our needs. So that's kind of high-level overview stuff. What does this approach actually mean for every component within that system? So each microservice is going to need its own Docker file, Jenkins file, and also some Helm files. Now, the Docker and Jenkins files are pretty similar across all the microservices. Docker, as I've said, is just containerizing the application, and Jenkins is, first of all, building the app, then creating the Java image. It's pushing that up to the Docker Hub. It's taking that image and their Helm files and building out a Helm chart, for the service, and then pushing that up to Chart Museum. And Docker and Jenkins are doing that for every single service in the system, and it's all pretty much the same. Helm, however, is a bit more specific because it contains the individual properties needed by each microservice. So, for example, within this system, the Kafka listener is connected to the Kafka stream, so it's going to have a Bootstrap server address and a topic name for that. It's also connected to router1 and the database, so it's going to need those URLs. Whereas router1 is concerned with sending data out to router2 and also these external services. And different from that again is retrieval, which is just concerned with connecting to the database and sending information back to this other service here. So all of that information data is vital to this system functioning correctly. And all of it kind of shifts and changes as we move up through environments. However, if we were just to define this system locally, all those properties would probably be set within each component's own local properties file, or maybe if we were to build up the whole system with Docker Compose, they would be injected with as Java ops. And Helm kind of uses this as a starting point for how it makes properties configurable. So take a closer look at this using the Kafka listener as an example here. So as said, we start off in the project's local properties file, and we can see the two URLs being defined here as custom properties. And because this is a Spring project, these will be injected with an @value annotation. This approach will also work with JIS-based applications. I've seen it work with both of them in the same system. Just don't ask. But some of these properties can stay the same throughout the environments, like the app name or the app description there, but these two will need to change. And it is through Helm that we are able to do that. So next is our first Helm file, and this is our Helm values file. And this is where the properties are defined through Helm. They've already been defined within the project themselves, but they need to be defined in Helm as well. And we do that over here through these two custom properties here. Now, the important thing to remember here is that anything defined within this file can be overwritten in an environment setting. And I mean anything in here. So we've now got a property definition, a project definition of a property, and a Helm definition of a property. The next step in the project itself is to join these two together. And that is done in the Helm template file. And as you can see down here, these two properties are being injected as Java ops. And it could not be easier. Project definition equals Helm definition. I honestly don't know how you could be more blunt with this. Now, this file itself is also used to create the Helm chart itself. So we've got the Docker image being pulled in here at the top, and also a couple of properties being set, which are purely for Helm's use only. So that is the setup for a single project. So what will happen now is Jenkins will go away and build a Helm chart using these files, and it will then push that chart up to Chart Museum. And as I've said, it does this for every microservice in the system. So we now have a series of individual charts just sitting in Chart Museum quite happily, just ready for us to use. And what we are now going to do with those charts is bring them all together into one system chart. And this is essentially just a chart of charts. And as you can see, the Chart Museum, the individual charts are being pulled in from Chart Museum here. I've accidentally cut off the full property name, but just imagine them there. And this is kind of the base of our environment chart, because the environment chart itself will be much more concerned with the individual details of every component. And as I've said, anything defined in the values file on the right can be overwritten in the environment file on your left. You can see that quite clearly here. So now we've got an environment chart that we can use to change the properties within the services. So let's say we've got 3 environments before production, each with its own environment chart and its own Jenkins job to build and deploy that chart up to the environment. Something to highlight here is that each individual environment chart is only related to its environment. So for example, we can't have a this development chart cannot be used in test, and the test cannot be used in development. So we'll start at the beginning at develop, and when we get to the end, we'll stop. So first environment, and it's all fairly similar to how it would be set up locally. We've got a WireMock database. The one change here is that the components are referenced with host names, and this is just a nice string to address the component with. It's easier than having port numbers flying all over the place. So that gets input to our router URL. The other thing here is that our Kafka name is exactly the same as it was in the local properties. The only something to consider here is that the external services for the router are not available, so we just have a few placeholders here. And to clarify, these URL properties, which have been set in the environment, will be injected into the Kafka listener instance in this environment. So in reality, these are the values that are used in its properties file. Okay, so build this chart, deploy it up to development, wait for tests to run, all that goes green, thankfully. And now it's time to think about moving it on to the next environment, which is test. So in test, we get access to the external services for routers 1 and 2. So just add those in straight away. In here, it's interesting to note that the host name for the instance has changed slightly, and this is because this is a totally separate instance to the previous one. So this is so we don't get confused between the two. Also in here, we have raised the logging level up to info, and this is just because we should not be showing debug logs above development. So the host name has changed here. So first things first, we're going to need to, the input topic has changed here within the Kafka listener. It's now capitalized. Who knows why? As I was starting to say, the host name has changed for router, so we need to update that within the listener. But our database is still the same. It's still pointing to the same WireMock, so we'll just leave that in place. Yes, so get this chart built, deploy it up to test, wait for the test to go green, and then start thinking about moving it on to our next environment. But before we do that, something worth noting is that there is quite a bit of duplication between these first 2 environments. And usually duplication is bad, is frowned upon, and we don't really need to know this thing. But in this case, it's about visibility, and a glance at this file can show you exactly how the system is wired together and what properties are being used within each service. And it's a lot better than having missing data and just not knowing. So the Kafka listener looks like it is not connected to anything except the router, where I'm going to assume that it's connected to a Kafka stream at some point, but really I can't be certain. I don't even know if these services are active or not at the moment. So in this context, duplication between these 2 files is a good thing. So as said previously, we're now thinking about deploying it to the next environment, which is test integration. And once again, the external services have changed, so we'll just update those URLs. Next, again, the hostname has changed, so we'll need to update that in the Kafka listener, which we will do first of all. And then we have a full database now for the first time. This is probably a test database, so not production, not live data, but still a proper database. And also we have a new Kafka stream, and for some reason the input topic has now changed back to lowercase again. Who knows what that's about? And as we are getting closer and closer to production, the traffic is increasing in our system. So we're going to up the number of instances in this environment just so we can keep everything flowing through nicely. So that's an awful lot of changes to make in one environment. So once we get this built and deployed up and our tests go green, I think we're just going to wait a wee second, just pause here, make sure everything is nice and calm and stable. And then suddenly the database team are yelling at us because retrieval is hammering their service. It's overwhelming it. It's going to bring it down. We need to fix this now, people. But that's easy, you know, that's just a change to the Helm file. You know, it'll take 5-10 minutes to get that through. Yeah, that's not fast enough. We're going to need it right now, folks, right now. Okay, let's, oh, it's a Kubernetes deployment. So what we can do is we can grab our deployment name, and then this is still broken. What are you doing, people? Yes, well, we're getting to that, folks. We can grab this base URL, and then we can point this off into the ether somewhere, and that should stop everything hitting the database. So just quickly grab the deployment name and edit that, and point this off somewhere, not database. And then we just have to wait for the pods to shut down and redeploy. And that looks good. Okay. We haven't heard database shout in about 30 seconds. So we'll just get this officially coming up through the Helm charts now. Get that built and deployed and out into the environment. And meanwhile, the database team have come back and said that it is actually an issue on their end with their traffic management policy. So they're going to work on that and get back in touch when they're ready to try this again. Now, technically, strictly speaking, that maybe wasn't the best approach to take. Editing live deployments is generally frowned upon. There's no record of who made that change, what the change was, or when it took place. But having said that, it solved the problem immediately while the exact same fix was coming up via a slower route. And you know, I don't know how many witnesses to that, so you'll be able to know the circumstances I did it under. But this is kind of where Kubernetes is used within a system. It manages the life cycle of pods. It enables users to access information about those pods and also edit some of that information. It can control the number of pods within an environment and also bring those up and down. So having just said that, why, when stuff was going wrong 2 minutes ago, did I not just reduce all the pods of retrieval to 0? And I'll say this, hindsight is a wonderful thing. And if it ever happens again, that will be the approach I take. But for now, database have come back and said, it's all grand, we're ready to try again. So once again, make the change to our environment file, get that built and deployed and up into the environment, but always be ready to kill everything just in case it happens again. But this time, everything seems nice and stable, and both database and the external service team are ready for this to go to production. So here we go. Big push, deploying to production at last. But really, we've kind of done this. So we've done this at least 3 times before, because we can consider each deployment to a new environment kind of like a mini rehearsal for this, except we've got 3 working systems to back up that this is safe to go to production. So final changes to make to production, we of course get a new host name. That's nothing new. Again, get a new bootstrap server, nothing new there. Update router 1, again, nothing new. Only scary thing here, and this is based on previous experience, is we get our full production database. But even there, we can be pretty certain that we've covered all our bases with this. So this is it. This is the microservice system finally going live in production. And that, of course, is far too important for a human to handle. So we're going to click a button and let Jeeves release this out. So we're going to watch on Kubernetes, though, and make sure nothing blows up. So we'll watch the new pods come up, the old pods come down. And that is it. We have shipped it all the way to production. Not bad, people, we did good. So just take a wee minute here, we pat on the back, you know, it's all gone well, nothing's crashed horrendously. And it's all fine, it's all fine. And now we move on to adding new features, because this is agile. Of course, we've got new features coming in all the time. So Router 2 now wants to talk to this service, and you know, that's fine. That's a change to its properties file, its Helm value and templates file, and all 4 environments. Obviously, there are changes to the code as well, but not really concerned with those here. So in total, that is 7 one-line changes to get this feature out to production. But that's not all, because Router 2 would now also like access to the database. But we've been here before, and once bitten, twice shy. So we're going to add a true-false switch into our code that can dictate whether or not we actually send information through to the database. And this will eventually be ripped out once this feature is stable, but it's a nice fail-safe to have in place. And so the system grows and changes, and these releases keep coming and coming. But because of this root that we have created with Helm and Kubernetes and Docker and Jenkins, that can just tick away nice and smoothly in the background and not really worry anyone too much. That's kind of it for an overview to this system. I just have a few conclusions now about it, and I'm going to start with all the bad ones first. So this can encourage some bad practice. As I've said, Kubernetes makes it easy to only make changes within its framework or within its within its console. However, there's no record of that, and we could have sent that information anywhere in the wide world, which wouldn't be great for GDPR, but it wasn't live. It wasn't a live database, so I think we were safe enough. But at the same time, you need to practice discipline around using it. There is quite a bit of time and effort put into the setup of this, writing the Jenkins files, building the Kubernetes environments, adding all those Helm files to each individual project. But that is a one-time setup investment, and really it's worth it to create this nice route out to production. The final point here is kind of a warning to anyone thinking of implementing some form of this, and that is that it is possible to over-automate this. For example, you can set up Jenkins that once the test suite goes green in one environment, it automatically proceeds to the next one. So a piece of code can go straight from development to production without any human intervention whatsoever. And at that point, we've lost control. And we can no longer examine what effect the changes have had on a system as a whole, and we can no longer give any external teams a wee heads up. Hey, we've got some changes coming through. Keep an eye on stuff and make sure we're not going to smother you. So within this system, you do need to set some boundaries for yourself. I feel like I've given some good real-life advantages for this system. However, I'm just going to summarize them here. It is really, really easy to connect a system of microservices together using the environment chart. It also is good to be able to see all the values used within each component at a glance. Because deploying changes to these services is as simple as changing one line in a file and deploying that, it is possible to get multiple releases out in a single day. Fine point control, so be it via Helm or Kubernetes, there is a lot of fine control over system behavior using this. Remember that anything defined within a Helm values file can be overwritten in an environment setting, and that is so powerful within itself. Things go wrong. Okay, that's just life, and this approach is built to handle those situations in a variety of ways. So, for example, instead of editing the deployment or killing all the pods, when database was getting hit, I could have just rolled back to a previous chart version, and that would have solved the problem as well. So that's three ways to handle that issue. I'm sure there's more. Those are the most obvious ones. This last point is something I have learned from experience, and that is that Slack bots are wonderful creations. We can have Slack bots set up for when our pods come up, when our tests get run and succeed or fail. We have ones for if our Jenkins builds fails. They are brilliant little helpers and are the one addition I would recommend to this system. And that's kind of it. Thank you very much for listening. I hope that's been informative and interesting. If you have any questions, burning or otherwise, please reach out in the chats now, or send them through to me at the address there. And once again, thank you very much for listening.
That was brilliant. Thank you so much. Yeah, I learned a lot from that talk. So a few little saved up questions here. So first of all, how much of that is actually rattling around in your head in day-to-day development? You know, so whenever you're writing your day-to-day Java or Kotlin or whatever, how much of that are you actually conscious of?
You're conscious possibly of the files within your own project. So your properties, your Helm value, and your Helm template, those three. And also then once you get those changes in, you're more focused on the environments and how they differ.
Yes.
Between themselves.
Cool. And then is there a better language choice out there than YAML, or any way to generate the duplicated bits of YAML, or is it just is YAML, you know, our glorious leader now, and it's too late to turn back, you know?
I took a risk using YAML. This is what we use on our project. I don't know any other way, and if people have experience of other ways, I'm sure there are. Yeah, I'm sure XML would be the alternative there. So it can probably be substituted without too much of a headache.
Yep.
She says.
Cool. Yeah, cool. And then finally, just to read this off the prompt here. So sounds like you have personal experience of this. How do you support testing when these changes will break other systems?
It's almost about forewarning other teams that these changes are going to come through, and almost stopping stuff before it gets to those systems. So the true false switches that I mentioned are a big part of our current system. where we maybe inform people that we have a change that's coming through and this is what it looks like, and they'll go off, fix their own stuff, and then when they come back to us and say, yep, we're good to go, we'll throw that switch and everything just flows end to end at that point.
Cool. Excellent. Very good. Thank you so much. So we will see you at the end for the group Q&A, but at this point, if I can dismiss you. Yay, very good. And if I can call on David for our third talk of the day. Thank you so much, sir. The floor is yours.
Thank you very much. Okay, hey everybody. Welcome to my talk, which is Smash Your Adapter Monolith with the Connect pattern. So this is basically a talk around introducing a pattern which we discovered and we put into place for how to break down like third-party HTTP adapters. I'll explain exactly how that goes in a sec. When we say breaking down, we're trying to introduce decent software practices, so like composability, testability, that kind of thing, understandability as well. But first, a bit about me. Hi, I'm David. I'm all of these things that you can see on here. I'm an engineering lead. I work in London. I'm a trainer, a bit like Garth. I've been lucky enough to do a bunch of speaking. I do a bunch of open source in Kotlin, and I'm a Google developer expert in Kotlin as well. So Kotlin is as you can see on the graph, my Kotlin is my latest thing since, well, I say latest since the last 5 years. So I hope I know a bit about it by now. But anyway, that's enough about me. Right. So this talk is going to have basically some coding. It's going to be Kotlin. Hopefully it will be understandable for everyone, but there are a few things that may be of interest to kind of features that we use that you might not be aware of. So the first thing is extension functions. A Kotlin extension function allows you to add functionality to any type, effectively. So other languages already have them. Java doesn't, so that's why it might be new. Also, anytime you see the invoke function, that is the same as a Java apply. So that basically means you can choose to treat an object like a function and call it like a function. Data classes, luckily Nicolai already kind of came across and mentioned that, though kind of what they are already, which is immutable records. Basically, Kotlin has them built in. So you get equals, hash code, and two-string methods built in, and it's all really useful. And the last thing is companion objects. Companion objects are a bit interesting. They are where Kotlin kind of hangs static state on, and they have several different uses, and one of them is kind of like kind of discoverability, which is the kind of the reason we're using it at the moment for this. Anyway, right, so if we take a typical HTTP microservice and we start looking at like the various areas of code that you might have in there. So we can kind of break it down into like your server-side API. That will talk to some business logic. There might be some data access, database, whatever in there. And there might be some third-party adapters talking to other external systems. Now, if we kind of focused on endpoints, which is our server-side endpoints, we tend to find though that code is generally quite well factored, and lots of attention is given to server endpoints and how things look. Very much when you have like web libraries, this is like what you see, and like, you know, oh, this is how you define your routes, etc., etc. So let's take a kind of example of what that kind of might look like. This is like an example server that's been written in HTTP4K, which unsurprisingly, because I'm maintain and creator of it. So as we can see here, what we've got is a server, and we've got a couple of endpoints, echo and health. And each of those endpoints is actually factored out into its own function, which means you can put them in different files. You can test them independently. So that's kind of nice decomposed stuff, basically. So that's all pretty kind of as normal that you would see in most frameworks, and that's what you see. If we go back to our diagram, and then if we kind of switch our attention to the back end, right? So these are API adapters. They talk to other services, and what we tended to find was that these bits of code kind of went a bit more unloved. You wouldn't get the kind of decomposition and the decent kind of breaking down of the code as you would get in the front end, as you get in like the kind of like server-side endpoints. And so what would happen is that you would end up with like masses of code all talking to the one service, like, you know, one thing with like 30, 40 methods. And that kind of attempted to I suppose it attracted like technical debt. So what we were discovering was there's lots of you've got these multi-hundred line objects at the back. Let's see what it would look like as well. So this is like a monolithic adapter, as it were. So similarly, this is a kind of a GitHub adapter that's basically built around a common shared protocol. So this, you can see it takes an HTTP client. The HTTP client is setting up the shared kind of protocol. Setting up an accept header. It might accept some. It might set some tokens or something like that for security. And then you each have each of these methods, which one of these methods basically equates to one server-side call normally. So you've got get user. He kind of gets user, and you've got like get repo lace commit. And the details of that aren't particularly interesting. What we notice is very rarely do these calls actually combine. Do they? You wouldn't call. Usually you wouldn't have, you wouldn't really have a function that called get user and then get repo lace commit. But if you would, then this is where you put it. And that would kind of increase again, once more, kind of like the bulk of the functionality that is in this kind of monolithic, this class. So if you imagine this class, but with 40 or 50 methods, it starts to get a bit unwieldy. And at the bottom, you can see this is how we will construct this, API. Kotlin doesn't have a new keyword, so we don't need to use that. So we can just call GitHub API with passing an OK client, and then we call get user. So we started to ask, how can we kind of get around this? Surely we can apply a pattern to actually kind of break this stuff down. And luckily we came up with something. We're christening it Connect. It's probably a kind of variation on a theme, which lots of these things are. I'd really like to know if people have seen it before or kind of very similar. We're not quite sure it's the command pattern, but as we go through, we'll hopefully kind of see what it might look like, and please let me know. So what does it do? The Connect pattern basically splits the monolithic adapter into separate testable and composable parts. Basically, the most important thing to us is that it's very simple to implement, and it's also, as we'll see a bit later, incredibly flexible in how you actually do it. So let's dive right in with the first concept. The first concept is an action. Now, an action is basically a unit of work that we're talking to an external system. Its model is effectively a generic type, which represents a single interaction, and its job is to marshal the domain request, which is like your version of the call, into the HTTP version and back again. So that's kind of what it is. Let's see how it looks. In Kotlin, we would define a kind of global kind of interface, which is like the generic, we're talking to GitHub action. Yeah, so and you see it's got these two methods on it. It's got a to request and it's got a from response. And we've got an implementation here, which is like get user, that implements the action. The return type, which was R in our interface, has been ungenerified to it's now user details, which is just a data class. And we've got these two methods on it. So the main thing here is that all the kind of inputs to this action, which itself is a data class, so therefore is has equality and all that kind of stuff on it. The inputs are passed as fields, and then the fields are passed into the request. And then once it's gone through that cycle of going to the client and coming back, we pass the response back in, and the response is basically there unmarshaled into our response object, which is our user details. We've got two functions here, we've got username from and user all from. Not really important what they're doing, just imagine they're kind of pulling stuff out of a JSON response. Cool, so those are actions. The second thing is the adapter. So the adapter is the only other concept, and the adapter's job is to take an action and convert it into basically perform that action against the HTTP kind of service at the end, the remote service. The adapter itself, as we saw in our adapter previously, its job is to configure URL security, that kind of stuff, all the kind of base, the kind of shared protocol stuff. Its model is a simple function that receives the action and returns the response, and that's kind of it. Let's see how that looks in Kotlin, and it's just this simple. It's an interface with a single function on it, and the single function takes this generified GitHub API action. So we had our get user action. We could actually pass it in. R in this stage is actually the user details, and it would automatically get back the user details object. You can see here the companion object, which I just kind of discussed earlier. The companion object itself is kind of the place where we can hang useful stuff off to in order to make the API kind of nicer, basically. And we'll see how that's kind of used or abused depending on your kind of point of view. If you use Kotlin a lot, then it's kind of it will be more natural to how we're going to use it than if you come from Java. So after we've implemented our if we re-implement our adapter now in terms of our interface, we've got a function which we're hanging an HTTP version of our API off of our companion object. And you can see how that ends up being used in the second line from the bottom, which is GitHub API.http. That's what that basically turns into. And we're doing roughly exactly the same things we were doing in the previous version, which is basically setting up that HTTP client. We're setting the base URL, we're setting the accept header, we can do all the tokenization and security stuff as well. That's all centralized around this. And then the main meat of what this does, is this invoke method. The invoke method takes the action, it converts it to a request, it creates the domain request to an HTTP request, it passes it into the HTTP client, which in HTTP4K is like a function itself, which returns a response, and then it unmarshals that response back into the domain type. And then so you can see here, well, once again, we're at the bottom, we can construct the GitHub API, and then we can call that GitHub invoke method by treating it as a function, because remember, that's what we said that invoke does. And we create our get user object with Octocat, and that should do the marshalling in and out of the HTTP for us. So within that, actually going back a step, what we see at the bottom is that the get user action is a bit more, it's a bit less friendly to how we've seen before, which is basically we need to know what we're going to pass into the GitHub. Now, in IDEs, this is less friendly. What you expect to see is GitHub dot and then control space, and then you get all the options of the things you can do. So this is fundamentally less friendly to the API user. But is there anything we can do for that? Well, the good answer is yes. Good news, because we've got Kotlin, and Kotlin has extension functions. So extension functions allow you to add functionality to any type, as we explained. So what we can do here is just kind of write a little kind of conversion method where we add a get user function to every GitHub API. And what that does is just marshal that username into a get user object, and then does the call to invoke, and then it responds with the user details. So it's just a small bit of code to give us that kind of friendly IDE kind of capability. And we can see we've done the same thing with get repo Laker Smith as well. And the bottom line, you can see now we've got the GitHub get user. That's exactly the same as we had before. So everyone should be none of the wiser, as it were. Okay, so that's the API. Now, composite actions. Now we might have actions that do two things. So we can. Well, the good thing here is we can actually create, in the same way as we created our previous action kind of actions, we can create little composite actions. So here we can say get latest user, and what we're going to do there is we're going to say, well, first we're going to get the latest repo commit, and then using that commit's author, we're going to get the user. So we've added another bit of functionality to our action to our adapter. But we haven't added it, but it is being completely self-contained. So all these actions that we're implementing are completely self-contained. They can be put anywhere. They can be put into their own little kind of, they can be put into their own source folders, or you can implement them as you like in your own project, and or in packages, all that kind of stuff. So it's portable and relevant. You should add them as portable and relevant to the place they're going to be used, basically. And you can see that by adding this extension function, we're none the wiser. As far as anyone is concerned, the GitHub API user is concerned, we've just added another bit of functionality. But what we've done is we've combined two bits of functionality that previously existed into a new bit of functionality, but we haven't increased the size of our adapter. Our adapter is still that one method, and all the other methods are actually extracted out. So everything's kind of extensible, and you can create new actions as you see fit. You can create your own versions of actions, your own versions of user details. Say you've got a user details object which only wants one field, then you can actually create that as well, because you're in control of as long as you implement that GitHub API interface, GitHub API action interface, you're all good. So testing. So testing is very important for all these things. And this is one of the things we really wanted to get out of this pattern, was to be able to independently, and like breaking down the adapter is one thing, but then decomposing it in order that we can test it is kind of in a simpler way as well, is kind of really important to us. So testing actions. So the good news here is our actions are data classes. So because our actions are data classes, this means they are easy to test because they are immutable and they don't have any surprises. Now, the good thing about we're using HTTP for K at the moment in this implementation, and in HTTP for K, the requests and responses are also data classes as well. So testing the actions becomes completely trivial because it's literally a case of take the action, turn it into a request, and then look at the state of the request that came out. And similarly with the response, it's exactly the same. So this kind of does your entire. You can put. You can obviously put kind of variations if things are null, and you might set various things on whatever. But at the end of the day, everything is controllable and very kind of defined in a very kind of bounded way. These tests won't interfere with other tests or other actions because they're all self-contained. Adapters. Now the adapter as well, testing adapter is very simple because it is just a simple function. So that means it's trivial to mock because it's only one function we have to mock, and we know exactly what it's going to return because they're data classes, and data classes are easily constructed as well. So what we're doing here, although this we're basically using mock K to create our GitHub API, and we can just say, well, we're going to take any user, get user, because we don't care for this test, we don't care what's in the get user. But because it's a single, a lot of the problems with that you sort of find with mocks is that when you've got a function that takes 20 arguments, then you have to decide which ones you want. Maybe you don't care about any of them, but actually maybe you just care that it got a get user message. This version actually allows you to just say, I don't really care about what it is that I get. I just care about this get user message. And then I care that I'm actually returning the user details. So I'm avoiding having to kind of actually care about any of those other arguments to the method. And you can see, but here this test doesn't test anything really because we're just testing the mock here. But you can imagine this GitHub API was actually injected into another thing, and the other thing which is like a business wrapper around it, and that's what we would be testing. But this is just displays that you can test the adapter, you can mock the adapter. Also, you can stub it very simply, because once again, it's a single API method with an action, and using like we had with Nicolai said with seal classes, we kind of basically do a similar thing if we defined our actions in some kind of sealed hierarchy. Or actually, even when we're not, we can use a Kotlin when expression and smart casting to actually provide individual actions and say, well, we kind of what to do under various circumstances. The nice thing about this pattern, when we're kind of stubbing instead of mocking, is that also we can decompose our functions, our get user and get repo latest committer functions that you can see at the bottom. They are also decomposed into small, individually kind of pure functions that only rely on the inputs to them. So these are also trivially testable and decomposable, and you can put them wherever you like, etc., etc. So this kind of also trivial. It kind of keeps you honest about. It stops these stubs also from becoming these monolithic things that you often see. Decoration. Once again, if you want to do something like recording, this is a recording GitHub API. We can basically delegate things down, and we can record actions on the way through and take action if we wanted to actually do something. We could set up. If we wanted to not mock, but if we wanted to do something where we kind of record these interactions to disk or a way which we could actually replay them later, it's really trivial to do. There's no 50 methods here that we have to implement. It's all one method, and we can take actions exactly on the actions that we actually really care about. So that's another kind of powerful thing about how this works. So one other thing that one question we need to ask was, the previous versions of the API that we saw relied on exceptions. We were basically we're relying, if something goes wrong, then we're relying on an exception being thrown. So it says, something to say, if the 8 response code wasn't a 200 or was greater than 399, then we're going to throw an exception as opposed to attempt to deserialize the response. The nice thing about this model as well is that we can vary our programming model. Now, functional programming models tend to rely not on exceptions; they rely on kind of result monad types. So in Kotlin, you've got various options. You've got like Arrow's got one, which Garth should know about because he's been writing non-stop about Arrow recently. And there's result for k. There are a bunch of them basically. But then, and you can also vary the program model with this to use futures as well, or any other kind of program model. It doesn't really matter what that R response type is, because the actual thing will support it. So we've got an example here, which is result for k. If we wanted to change our result type in the from response method, you can see we're now returning this result type instead of this standard R. So instead of throwing an exception, we would basically wrap that exception in a result type, and then we can rewrite our actions using this particular model. So you can see here that in the from response method, we're checking the successful status, and if it's a less than 399, which is what that does, it returns a response object, a success object. Otherwise, it returns a failure object. So this allows us to vary, even though we've got a single function, we can actually completely vary how we want to apply it. And it's only the actual adapter itself doesn't care, because the R type that's passed into it is completely generic. So all you could have some that do responses, some that do either. That's the kind of the beauty of the model, is that it gives you options to program exactly how you want. So in summary, yes. So that's kind of it. So in summary, the connected pattern, it's very simple. Hopefully, hopefully I've managed to explain it. It's like 2 simple interfaces, pretty much. It gives you testable and composable kind of actions and code, so we'll be able to split our third-party API adapters down into those small pieces that are easily testable and actually workable. It's flexible on the model, your programming model, so people can work as they wish. And also, actually, it's not bound, although we're using it with HTTP here, it's not bound to any particular protocol at all, because it will work with any kind of request response protocol that we can come up with. Now, the examples that we came from here are kind of rough version of what we have created in HTTP Connect, which is like the reference implementation that we created while we were kind of trying to prove this out. HTTP Connect basically provides a bunch of featherweight API adapters for, mostly it's AWS services, and it provides a bunch of in-memory fakes and storage as well, so you can kind of do in-memory testing. The reason we wrote this was because it was written to not just test out the pattern, but also to replace like the Amazon SDKs in serverless functions, using Kotlin in serverless functions, because the AWS SDKs are actually quite heavyweight. They bring in megas and megas of actual dependencies, including Jackson, et cetera, et cetera. And we wanted something really lightweight. So the Connect adapters there's no reflection base, which means it works really well with stuff like Graal, and it also really works well with serverless functions as well, because we're keeping that package size down, so that kind of keeps your kind of spin up time really small as well. So that's all available on GitHub. You can kind of go and have a look, or check me up on Kotlin Slack. And if you've got any questions. But anyway, thank you very much. That's me. These are all the things, all the various bits and pieces, traditional slide. That's it. So thank you very much. Garth, are you
Yeah, no, thank you for a wonderful talk. Lots to take away and try out there. I think you anticipated the first question, which is that this is going to be very useful in a cloud type scenario where you have lots of external services that you want to fake out and so on. So maybe to ask something slightly different. So whenever you are trying to fake out an external service, is it then the adapter that you're stubbing, just to be clear?
So, well, it gives you an option, right? So normally what we found is that people like to stub out their business layer, right? So if you imagine you've got your business abstraction, you've got your HTTP client inside it. If you stub out the business abstraction, that's the traditional mechanism to go down, then that's fine. The problem with that approach is that you cannot know what's going to happen when it goes wrong, right? So when S3 takes more than 2 seconds to respond and your request times out, how is your code going to react? So what we tend to do is actually mock out. We try, and the point of Connect was to basically test completely end to end. And the fakes that we've created in Connect basically have a chaos mode where effectively you can get them to either throw exceptions or return 500s or run out of memory or all that kind of stuff, and it's all just built into the fake. So our approach is to test completely end to end, and that's also the kind of the HTTP mechanism is also to test completely through your adapter layer to the other side. And the other thing is that what is nice is these adapters are also, you can launch on a port. So you can launch them, they're just servers. Because using the server as a function model, which exists in HTTP, there's no difference between a client and a server, and it's just an HTTP handler because the interface is identical between the two, basically.
Cool, very good. And then the different actions that you have, how are they grouped or stored or collected, as it were?
Well, you can put that's your option. You can do exactly what you like. So you can have. So you might have, for instance, what we had was we would have a module that just had just the transports out, so that it sets up the token and where it's going to go, et cetera, and all that kind of stuff. And then every project can implement their own API adapters for whatever it likes. So you can build little libraries of them. You can put them into. It's complete. The thing is, it's almost too many options. So I can't answer that question because there's too many options. I know how I do it, but I think I've done enough talking.
Cool. No, it's a really nice combination of an OO model and functional principles, and using the best of both, so you can see how each fits together really well. Cool, very good. So just looking at the time, we're a little bit short of time. So if I can bring on the other two presenters, please. Excellent. And this is your opportunity to ask each other difficult questions. So I'll start with the first difficult one. So in the great language wars, where do you think we're going? So, Java was obviously the leader and then fell behind a bit and is now catching up at an extremely rapid pace and so on, So is the thing that will take over from Java, or are we in a 3-horse, 4-horse, 5-horse race for the foreseeable future? And is it a good thing that everybody's bouncing ideas off one another and cross-pollinating, as I like to put it in a very polite way? So what do you think? What's your opinions?
I'm too young. Java was ahead at some point. No, seriously, no.
Make me jealous. Yes, yeah. No, I remember Java World Online magazine, and everything you needed to know about the whole world of Java was in there once a month, and that was great. So yeah.
I found it interesting, right? David mentioned the data classes and records, right? That there's a direct relation between the two, and I think it's a matter of fact that I think most languages, not just on the JVM, but every language that now is created, of course, takes input from what happened in the past and tries to incorporate that and tries to identify what are the largest problems of languages that have been there before, and sometimes down to a specific ecosystem, right? Like Rust does not try to solve all the problems, which is like one specific problem, one specific area, and then tries to come up with the best ideas for that. And then, of course, when you create a new language, you can just pick and choose and try to make the best language you can. And then if you're past that point and you have users and you don't want to break backwards compatibility for them, then you're in a situation where you still want to pick things, but you probably want to be more careful and want to spend more time thinking like, how does this best fit? And I think the interesting bit is that, for example, languages like Scala and Kotlin, they arrived at that point as well, right? So they cannot just willy-nilly just do all the new cool things anymore. They also have to think about, well, what happens to our users then? Can we do this in a way that's backwards compatible? And also, it fits cleanly into a language, right? Should not appear to be bolted on.
Yeah.
And in that way, I think that most languages are in their own race there, right? And so I think every language just tries to be the best language it can be, but of course being cross-pollinated, as you said, like inspired by other languages. I mean, it would be stupid not to, right? Like, how could you like do Kotlin or do Java or do some other JVM languages or not JVM languages and sit on your horse and be like, nope, I never looked at another language. That's the best way to evolve mine. That would be kind of weird.
Yeah, I tend to agree. I mean, I think. I mean, I'm thoroughly like Kotlin through and through now, but I like the fact that I hate writing Java less than I did because of the language, So it's forced. Yeah, exactly. It's forced. For a long time they had, the owners of Java, whoever it is that week, had it too easy, right? They had no real pressure to, let's say, to improve, but now they have, which is good for everyone, and that's cool. Yeah. One thing, I mean, there is actually one thing that I do, and I actually was going to ask it earlier, actually, but I thought I wouldn't interrupt you, Nicolai, which was the Streams API, which is interesting. It was very interesting to me you said that you didn't use parallelism, because actually, to me, the entire thing has been completely, I think, compromised, the API, by the inclusion of parallelism, just because of the weird kind of collector thing, which you don't see in traditional functional languages at all. But the only reason that's there is in order to actually enable like parallelism. And it's interesting.
Reason, I think it's only to decouple the Stream API, which is lazy and generally speaking has a different approach than the collections they will otherwise be, right? So there is no map on list. I mean, that's fine. I was more talking about, because you have lazy sequences in Scala, you have them in Kotlin, but they don't have that collector API, and it does actually make things incredibly difficult to tell you. So something like a fold, which is an incredibly popular kind of functional paradigm to write, is incredibly hard to write in the Streams API. And there are things about checked exceptions not being supported really well, and that's so there are, I think, the Java Streams type in collection interfaces has been implemented better by other kind of Var and totally lazy and those kind of things. I think there are actually, I mean, it's good they're there, and it's good that, it's great that everyone's not using for loops, right? Because that's just mutable. It's all the nice stuff. It's all the immutability, and we're going in the right direction. It's just... Maybe it doesn't make sense to dig too deep in this conversation then, but my impression was that Kotlin, which has map, for example, on its list types, those are all eager, right?
There is sequence.
Sequence, okay. So then when you go back to a collection, like, would you have to do that? I'm not familiar with that too much. Obviously,
you switch back to, you have to convert a sequence back into a list.
Yeah, but isn't that kind of like what the Stream API does? You go from a stream to a list?
Yes, it is. I'm not saying no. The actual concept of the Stream API is absolutely fine.
I mean, just like the way that the collector API specifically is like written with, like, you have to have like create an empty. I know there's the collection step at the end. That's mildly annoying, right? I get that. For example, I used JavaScript a lot in the last couple months, and it's really nice to just like white map, and then you're back to your array. Like, there's no collect step, there is no toStream step, right? It's like it's all the same API.
Yeah.
But I thought that was what you're saying, like the step, like the collect step, like just having to write collect to list is kind of cumbersome, where you could just say, list map, and you get back a list.
Yeah, that's precisely. Yeah, that was precisely my point. Sorry, I probably didn't explain it well. It's fine.
Yeah. And the thing with checked exception, by the way, I thought about the same thing. Like, what the check? That's so weird. But trying to write a lazy Stream API that deals with checked exceptions, given Java's generics. I tried to think how that could work, and it actually doesn't, because so you have like a stream, it has an operation, and it can throw an exception, but it doesn't do that then and there, right? It just does it later during the collection phase. So you somehow have to string that generic, that exception type along. But that works well as long as it's just one type, but then maybe a later collection throws another exception. And then
we're into monads, aren't we?
I actually sat down and thought, okay, let's do this. This can't be that hard. And it turns out, well, it kind of is. Damn it.
Oh, dear.
My favorite example is, the version of reduce where the initial value is of a different type than the elements in the stream. So you have to pass in the third lambda, which is the combiner for should it be in parallel. But if you're not doing it in parallel, you can just do A, B, arrow null. Because I remember when I was first looking at Java, looking at that for about 4 hours, and then finally saying, so if I do A, B, arrow null, It works. What? And that took a wee while to get used to. But anyway, moving off topic, that this could be a bash in its own right. In fact, this could be the language bashing bash. We might do that at some point. But any other questions anyone would like to ask anybody? Going once, going twice.
Yeah, I just had the record data classes one prepared. So actually, I don't have anything else, I have to admit.
Fair enough, sold, because we're at time anyway, so we will leave it there. But listen, everybody, thank you so much for contributing. Yeah, so thank you to our presenters, and thank you to everybody who turned up, and hope to see you next time. So thank you very much indeed. And
thank you too, Garth, for the invitation, and everybody else.
Yeah. Thank you.
Thank you. And we're out.